Okay, so this problem reads, a truck with a radius tire of 0.420 meters travels at 32 meters per second. What is the angular velocity of the rotating tires in radians per second and in revolutions per minute? All right, so we know the radius of the tire is equal to 0.42 meters. And we're told that the truck is traveling, the velocity of the truck is equal to 32 meters per second. All right, that tells us we want to remember that the velocity is, the linear velocity is equal to the radius times my angular velocity. And I want my angular velocity. So if I solve for angular velocity, I get the angular velocity is equal to the linear velocity divided by the radius. My linear velocity is 32. My radius is 0.42. And so I get an angular velocity of 76.2 radians per second. So that's part A. Part B says, well, what is that in revolutions per minute? So we're going to convert radians per second to revolutions per minute. So we have 76.2 radians per second. I know in 2 pi radians, I get 1 revolution. And in 60 seconds, I have 1 minute. And so I determine that the revolutions per minute is 728 revolutions per minute. So using those relationships between angular velocity and linear velocity or tangential velocity, the tangential velocity is going to be the same as the velocity of a point on that tire that's rotating around. It goes around 1 revolution in the distance that the truck moves forward. So the velocity of the truck is the same as the velocity of a point at the edge of that tire. Therefore, the linear velocity we know is related to the radius times the angular velocity. So I can solve for angular velocity and then look at that as revolutions per minute. Good job.